reached the end, my battery percentage was much higher. It went to 55 actually. So not just that it did not consume, but it also produced 3% extra. That is like easily 6, 7, 8 kilometers. So in ghats, you see a very evident rise in the battery percentage.
And also, regarding the charging pattern, so you mentioned that AC and DC both charging patterns are. So most probably that we see when we use when we park our car in our house. Okay. So that lasts around 8 hours, 9 hours. So what is actually the best possible way to increase the battery life? So we should use this AC and ACs simultaneously.
Only AC is advised.
Okay.
Only AC is advised, but when you are traveling long distance, charging AC is not at all a problem for the battery. We just suggest that every 4 to 5 cycles of DC charging, charge using AC once because it will help in cell balance.
So what was the charging time which you took for DC charging? What was the time?
Charging time, so like I said, right, from 20 to 100 it takes about 15 minutes max.
Okay.
Yeah, same thing, 20 to 100 in AC will take about 7 hours.
So basically, easy charging. In 1 hour, you can charge it for 25 kilowatts. The battery power maximum is 30 kilowatt hour. So in 1 hour, you can do only 25. So you have that 5 for a previous spending. So overall, it takes about 90. So that's the number.
Mainly this the battery capacity, and that depends upon the aerodynamics of this vehicle also, right? The performance as well as the battery consumption. So as you mentioned earlier, like it's just hardly 6 kilometer difference between the Tigor as well as the Nexon. Okay. So this battery capacity, so like as you mentioned in your first slide, Tesla has already introduced. So it's providing around 550 to 600 kilometer range.
100 kilowatt hour.
Yeah, correct.
This is camera.
This camera lighting.
Okay.
Manufacturing all the batteries that you offer is 100 kilowatts for all them.
Thank you. Hi. It's a very strange question. What was the psychological impact that you guys had before you started the travel and during the travel? I know before you started the travel, you had to get some info from the Telegram group, and throughout your travel, right? You talked about percentage of battery. Even one of the screenshots had 5% battery. Now, human mindset is anything that goes below 20% these days, the battery icon changes from green to red. But in petrol cars, we never cared about the E symbol because we knew, okay, there is another 10-20 kilometers. What was your psychological impact during your journey? And did you regret there were many petrol cars flying around you and you didn't have the luxury of a petrol car?
Okay, two good questions. One, the psychological impact, absolutely nothing. This 5% charge was when I traveled from Trivandrum to, so the nearest charger is here in this Ginger Hotel out here. Yes, so it was only this stretch that I managed to travel with 5% charge. And now because we've driven so much, right, we have full confidence in the car that every percentage is going to give me about 2.5 kilometers. Yes, so I can easily calculate that. And during our entire journey, we honestly never cared about the battery. It's because we had already planned, right? And I know this for a fact, my car is shortly going to travel 230, 240 kilometers. Yes, but I'm going to stop at about 190 kilometers. So I never went from, let's say, a 5% to 100% in any of the charges. I always stopped anywhere between 12 to 20%. Yeah, in fact, some of the charges we would in fact go to 50% because we would want to do a much bigger stretch after that. Yes. So honestly, there was no psychological impact, but yeah, I would agree to one fact that we saw a lot of petrol blasts flying, and we thought we couldn't drive so fast is because we wanted to save battery. I agree on that one.
About the psychology of anxiety, there was only one instance where we went to a station, where we reached a charging station and it was not working. There was only one case like this, but because of the planning, we knew one was just 5 minutes from that place. So we had an alternative option. This only happened once in the entire tour. And as he said, everything was planned. So we knew exactly we have a charging station waiting for us with so much of range remaining for us in the car. So it was pretty comfortable.
This happened because of one reason.
App getting updated that night from 12 a.m. to 4 a.m. So this is the reason why we didn't have that charger available. But other than that, absolutely fabulous experience. Yeah. Okay, thank you so much. Yeah.
While going downhill in an IC engine, we use the engine as brake. So it will be acting as a brake.
Correct.
So in an EV, what is your experience?
Yes. So in
it is
an
going
EV,
like freely or
no. So there are different options available here. So Nexon doesn't offer variable regenerative modes. Okay. So like I said, what is the whole concept of regenerative braking is when you leave the accelerator, there is automatically brake getting applied. Okay. It's not free moving. Okay. So answering your question, there is full brake getting applied properly. So you'll never experience that it's freely moving and the speed is increasing because we are going downhill. Right. That will never happen. But the latest Nexon that got launched today has variable regen modes, which MG already has. Okay, so if you want, so there were times when we wanted the regen to be 0. Okay, because we were going downhill. If the regen is 0, the speed will not gradually reduce, and I can in fact cover much more distance with 0% change in battery. Yes, so that is something that's offered in the new Nexon, where I can set the regen to 0. I can deliberately put it to a state where there is no manual automatic braking happening.
okay. Then the brake is if we are putting it into 0, then you have to apply brakes.
Apply. You will have to apply brakes. Yes. Okay. Yeah. Yes.
So hi Gautam, I have a question. So there are serious apprehensions regarding the battery performance, battery health, not in four-wheeler segment, in two-wheeler segment. So many EVs that catches fire, and the technology, the battery technology, the EV technology is in a transition phase. So is this the right time to purchase an EV?
Okay. I think Shyam and Chandan will be in a better position to answer this question. But one point based on what I have learned is, honestly, there's no, batteries catching fire is not because of the temperature outside or something. It's basically to do with the construction of the battery and the quality of cells used. That's what I understand. So none of these batteries have caught fire because of the temperature outside. They've caught fire because of short circuits. Okay, so temperature outside has got nothing to do with the batteries catching fire. And if you look at four-wheelers, I guess the technology is fairly evolved. Tata has got multiple cars today, and all of these batteries are performing really well. Yeah. Okay. Thank you. So quickly, I'll just like to give a little context here. So we went on to explain you how exactly we as users look at an EV and what is our experience been. Yeah. After us, we have Dr. Koshi here, who's the CEO of Trespa, who's going to be speaking about opportunities in Kerala. And followed by this, we have two amazing startups working out of Kerala, working in the EV space. They'll have a lot to share about what they're working on currently. Yeah. So we can welcome Dr. Koshi now.
Zahir bro, ഒന്ന് കണക്ട് ചെയ്യോ ഷെയർ ആവുന്നില്ല.
I have a message in all my groups. Nobody is able to hear. No, what is
Okay, good evening everyone. Okay, first of all, I would like to thank the organizers for inviting us for the meeting. And I will just give the broad context and the overview first, and some of the activities which happen in Trust Research Park. And after which I would invite my the CEOs of two of the startups based out of there, which is Mr. Sham and Mr. Chandan, to explain their experiences in the electric vehicle space. So I'm just giving the broad context first. Okay, so as you know, the electric vehicle industry, currently it is more than US dollar 300 billion. And if you look at the growth of the electric vehicles, you can see that currently the numbers are more than 68 lakhs electric vehicles are there globally. Okay. And the growth has been quite large in the recent years. That means it is from 2020 to 21. There is around 108% increase. So currently, if you look at globally, 8.3% of the overall number of vehicles are electric vehicles, and that number is increasing over the years. And one of the reasons why this is happening is due to the policies of different governments across the world. Because you know the advantages of electric vehicle, like the less pollution and the less effect of greenhouse gases and all those things like that. As a result, more and more countries are focusing on the electric vehicle space. I will just give you an overview first. If you look at the different countries across the world, for Canada they have a government document which states that from 2040 onwards, all the new vehicles should be electric. Similarly, in China by 2020, 25% should be electric vehicles. France, Germany. So you know, from 2025 or 2030 or 2035 onwards, there is more focus on electric vehicles, and gradually the ICE engines will decrease. And you see there is a more focus on that is across different countries because of the environmental impact and things like that. Similarly, in Scotland, South Korea, Sweden, United Kingdom, in all these places, there is a target on the new sales on bringing more number of electric vehicles. In addition to that,
the government is focusing on that. Many of the automobile manufacturers, they also indicate that many of the new vehicles that they produce will be electric. For example, for General Motors or Ford or Volvo, so many of the automobile manufacturers also focus more on the electric vehicle space. So there is a good future for electric vehicles. The investment bank UBS says that from 2025, around 20% of all the new cars will be electric. Similarly, by 2030. So you see that as years pass on, more and more the percentage of the number of vehicles that will be electric will be increasing. So the statement by Elon Musk that we have seen a real shift in customer perception of electric vehicles, and our demand is the best we have ever seen. Okay, so what I explained was the global scenario. Now coming to the national scenario in India, we have the national EV policy. It was framed in 2012, but then later on the FAME 1 and FAME 2 were announced. That is the fast adoption of manufacturing of electric and hybrid vehicles. And as a result, there is a lot of incentives which are provided for the buyers as well as for the manufacturers in all the initiatives. Like for example, for FAME 2, it is about 10,000 crores rupees which is being provided as the incentives. And in addition to that, after the national EV policy came, many of the states have developed their own EV policies. More than 50% of the states in India have the electric vehicle policy which is being formed. And so all this will ultimately include the financial subsidy on the purchase or exception from road tax, registration charges and so forth. Also the initiatives for bulk purchase of EVs and for the infrastructure development, the fund for the charging stations and so forth. Yes. Yes. So in the state government has formed an EV policy in the year 2019, and as a result of it, there is a key focus areas. One is on the component manufacturing, on the EV components. So what they suggest is ultimately there should be centers or attract investments in the state where more EV manufacturing can be promoted within the state, and also on the electric vehicle manufacturing in the long term. That means there should be more an ecosystem for development of electric vehicles should be created within the state in terms of the R&D facilities or infrastructure facilities and so forth. And also the centers of excellence, that is the skilling centers which can incorporate more of skills in the electric vehicle domain, that should be within the state. So this was in 2019. They set some ambitious targets, but again we are yet to achieve that. But then those were all there in the policy statements. Okay, now after the state policy was being formed, there is an agency called KDISC, which is of the state government, and there is actually a strategic, an agency which focuses on the strategic initiatives of the government, and they also took it up as one of the major areas to be focused on, which is on the electric vehicle. And as a result, they focused on creating a consortium within the state, which includes VSSC, CINDAC, and the Titanium, and Trust Research Park was also part of that consortium. And their main focus was to create an ecosystem, typically to look at the materials available by Titanium and to look at how the cells can be manufactured by VSSC, and CINDAC looking at the power electronics side. And also our focus area was on the drivetrain, that is the motor and the controllers, the design and development of that, and also to set up some facilities for that. So that is still ongoing. KDISC has got some plan for enabling this electric vehicle ecosystem within the state. Okay, as part of it, in this, I will just explain about what exactly we are doing in that regard within Trust Research Park.
So we have two centers of. I will just explain about Trust Research Park. That is a institution with a Section 8 company which comes under the state government of Kerala, under the higher education department. And we have created two centers of excellence there. One is on the chip design, that is on the processor side, which focus on the RISC-V process and ARM process and so on. So these companies actually look at creating the chip design and one of the areas what is being focused on is a processor for the electric vehicle. That means a RISC-V processor which is customized for the electric vehicle. And in addition to that, there is another center of excellence which focus on the electric vehicle. That means there are some startups in the area of electric vehicle, some of which are focusing on drivetrain development and all. Their main center is in Bangalore, but they have a unit here which focus on the drivetrain development starting from all ranges, from two-wheelers to buses and trucks and so forth. And then there are some other startups like what Cito Motors and engine dealers and all. They'll be explaining their experience later on. So this, in addition to that, we also are planning to set up a drivetrain testing facility because we do not have a very state-of-the-art testing facility for drivetrains within Kerala. So now KDSK is focusing on funding that to create a state-of-the-art facility for testing drivetrains, which will be useful for the startups focusing on drivetrain development. So KDSK is funding for that, and we are planning to set up that. In addition to that, there is a hardware and loop simulation lab, which is a HILS lab. And so we also have the software like ANSYS, Solter and all. And we also have an MOU with Tata Elxsi for the setting up the HILS lab. And now we are extending that to the drivetrain lab as well. And also, as I mentioned earlier, we are focusing on the electric processor for a processor specifically for the electric vehicles, which is a RISC-V processor. As you know, the RISC-V is an open standard, and you don't have to pay the license fee like ARM and all. But the field is maturing, and we are going to develop a EV processor specifically for using RISC-V. I think as you already know, there are some of the issues that needs to be addressed with regard to the electric vehicles. One is with regard to the increasing number of charging stations and the range problem, cost of the electric vehicle, improvement of battery technology and so forth. So we have the different startups within there focusing on many of these areas. And the typical typical problems that are trying to be addressed, or some of the research problems in this area on the battery life prediction, increasing the battery life, then about the IoT based systems, motor design, controller design, battery recycling, EV chip manufacturing and so forth. So there are a lot of research problems in this space, and we try to engage with the startups and also with academia to look at how to have effective some of the solutions to each of these areas, especially R&D on each of these focus areas. So I'm just setting the broad context now. So now we have the engine dealers. Sham is heading that, and Chandan is also here. So now I'm handing it over to them for them to elaborate more of their experiences. Thank you.
So FAYA is more of interactions and getting more connections in the people of similar interest. So if you have any other questions, that is, you can continue. Then or if you have,
ലിങ്ക് ഷെയർ ചെയ്യാൻ നമുക്ക് ക്ലിക്കല്ല
I think that I am not aware of that. Only thing is, what is the policy document which is being published? by the government of Kerala is there, which is in the year 2019. So they are following that. With regard to the subsidies, whether they have any plan to incorporate and all, I'm not aware of.
So basically we started with what an EV is and understanding the basic difference between an EV and the car that we drive. And then we went into what are the opportunities out there, because normally people think like this is something that is we have nothing to do in that space, right? Right now Dr. Koshi was able to explain us like how open the area is, and there might be a lot of areas that we guys can contribute on. And now let us see what is happening right now in the innovation space in Kerala.
Thank you. Myself, Shyam, Managing Director, Engine Dealers and Consultants Private Limited. We are a member of Trust Research Park, CET, Trivandrum. We are popularly known as in the brand name Innovation Experience. Engine Dealers and Consultants is our registered name, commonly known as the brand name Innovation Experience. Main areas which we are working: solar powered waste management units, solar inverters, peak load minimizer systems, solar powered irrigation systems, electric vehicle retrofit kits, multi-purpose electric three-wheelers and solar poles. Mainly our area is renewable energy. We started our company with solar as the main product. That means solar products. We started with solar powered peak load minimizer as the main product, and we got patent on that in 2015. And right now we are working on retrofit kits for electric two-wheelers. Actually in Kerala, law is coming saying that after 15 years you have to throw away the vehicle or scrap it. But electric vehicles, we can convert these petrol vehicles easily into electric vehicles by retrofitting it with the electric conversion kit. It is very much applicable for two-wheelers and three-wheelers. We are not thinking about four-wheelers right now, because four-wheelers, the bigger companies like Tata and Mahindra is coming with excellent designs and new products which is far ahead than retrofitting. So it is very applicable for two-wheelers and three-wheelers. This is one of the solar assisted rickshaw which we designed and tested in 2017. Right now there are a lot of rickshaws available, but this was one of the initial R&D project which we have done in 2007. In Kerala there are 44 rivers, lot of backwaters, thousands of water bodies. We are always thinking about electric vehicles, electric two-wheelers, three-wheelers, and I think we are not thinking about possibilities of electric mobility in the water bodies of Kerala. Tourism is the main industry in Kerala. So we thought we should think differently. We should think in a different way, so that we should not get into the busy or the competitive market where Tata, Mahindra and other Tesla and other companies are, are competing. We are actively doing a lot of work in electric and solar board areas. And solar is the area which we are focusing. Electric vehicles can be, or electric boards can be easily converted into solar. And it is ideal for Kerala because we got a lot of tourism as well as backwards. This is one of the boats which we designed after the 2017 floods. We all remember that after the floods or during the flood time, we were looking for boats. No boat was available in Kerala for rescue. At last, the fisherman community came and rescued the people with their boats. I think you all remember that story. Just after the floods, we designed and developed this twin-hull boat, multi-purpose boat. It can be used for tourism purpose during normal times, and at the time of emergency, you can simply dismantle it. You can carry it in a three-wheeler auto rickshaw or three-wheeler pickup, and it can be taken to any place where emergency is happening or flood or anything is happening. You can just put a outboard fossil fuel engine, that means petrol engine, and it can be used for the rescue purposes. At that place, the electric engines or solar engines will not work. Because you need, at the time of rescue, you can use this fossil fuels, fuel engine. This is highly stable, and you can see a small ladder in the side, which is foldable. There was a news that time saying that a person showed his back for a lady to get into the boat. So we thought we should design something so that people can get easily from the water body into the boat. And that ladder was used for that purpose. This was another solar boat club project we designed, and we believe there is an opportunity for hundreds of solar boats or electric boats in Kerala, and this was one of the first solar boat club which we tried at Palani, Trivandrum, and these boats are still there. Coming back to retrofit two-wheelers, we have tested the retrofit kits in Splendor, Shine, and Activa. And right now we have our retrofit kit tested with the ARI, and we are waiting for its final approval. We have tested and approved. We have tested and manufacturing these kits not only for our company. We are ready to give these kits to engineering colleges and polytechnics and even ITS in Kerala to begin their own startups. Because skill development is very important, and manpower is much needed in this area. When I went to a two-wheeler or three-wheeler service station, these mechanics, they are not aware about electric vehicles. They are saying that, are you speaking about alien technology? Yeah, we don't know anything about electric vehicles. But electric vehicles are running here. Even Tata is giving electric vehicles, but I don't know how much manpower is available for the maintenance. It's still we lack a lot of manpower for this electric vehicle maintenance. So there is a great opportunity in this area. If we start training centers at our engineering colleges, and even ASAP is here, ASAP can do this. Our company is interested in starting training centers and testing centers for the electric vehicles. So this is another area which we are focusing. I want to tell something more. In Technopark, here in Technopark or even in a college, hundreds of students are coming in normal bikes, hundreds of employees are coming in fossil fuel bikes or petrol bikes. Imagine if they are converting, 100 employees are converting their vehicle or the two-wheeler into electric two-wheeler by retrofitting this kit. And they have to charge it at their home. But if the company or the college is saying that, come with your bike, we have a solar shed here, charge it here. So at 8 o'clock or 9 o'clock, they can come to the office or to the college. They go to their job or studies. The two-wheeler will be resting in the solar shed, and by evening when they are back, it will be fully charged. So that they are not depending on fossil fuel or electricity or KSCB or the grid for charging. We are going to celebrate the 75th Independence Day, but still we are depending on diesel or coal for our energy needs. For example, 2 weeks back, hundreds of trains were cancelled to move the coal. That means we are not independent. We are still dependent. So think about getting clean and free energy from the solar for running the electric vehicles. That's where we will get real independence. What our company is thinking is we should make some steps or some initiatives to make our country energy independent by introducing solar powered charging stations along with the electric vehicles. That's one of the goals of our company. We are into some other areas also. This is an electric vehicle from Ito Motors. I think many of you might have heard about Ito Motors Hyderabad. Actually, they are a subsidiary unit of BYD, the biggest electric vehicle manufacturer, and we are already a distributor for this Ito Motors in Kerala. Our first showroom is going to be opened in Calcutta within next 2 months. So initially we are going to deal with 3-wheelers, and these 3-wheelers we are going to not just multi-purpose 3-wheelers. That means some 3-wheelers will be used for carrying food waste or the waste from the houses. That means it will be deployed in waste management areas. We are already working in waste management sector. We have a joint project with Kerala Agricultural University, and we have developed world's fastest food waste to manure converting machine and mechanism. And it is going to be deployed in Shankamugam within next 2 months. That's another area where we are working, waste management. And these machines can be installed inside the 3-wheeler, and it will be traveling to the houses. It will be taking the food waste, and it will be converted into manure, and it will be sold in the same vehicle itself. That's one of the projects with the 3-wheelers. This is another area which we are interested. That's electric 3-wheeler hub in selected areas. For example, near the railway station, if we are installing a solar powered or an electric vehicle hub with 10 auto rickshaws. So 10 women drivers will be there. 1 woman technician will be there. 1 male security staff will be there during night, and yes, all the vehicles will be kept in the solar shed, which will be connected to the grid and which will be charging the rickshaws during the off-peak time. That means after 11 o'clock in the night. It will be charged by using a timer, so that there will be no load on the grid during peak hours. And these women can drive these rickshaws, and they can find livelihood for 10 to 12 families. We have already discussed this thing with the government, and together with Anavat or KTS, we believe we will be starting these projects within next 1 or 2 months. These are some of the projects which we are planning to discuss and to start with Kerala government. That is e-vehicle hub with solar charging stations, e-vehicle and repair and maintenance, e-vehicle repair and maintenance training for women. That means we want to start training centers for women. Especially we would like to work with Kudumbasri, so that we can introduce more women mechanics and technicians in electric vehicle field. It is not so tough as the fossil engines. Any women can easily do the repair work of these electric vehicles. So we would like to start the training centers here. And waste collecting electric 3-wheelers, waste processing electric 3-wheelers. Another thing is electric 3-wheelers with refrigerated cabins for milk and vegetable vending. 50% of the vegetables become rotten or it will be damaged due to high temperature, due to sunlight while vending. So in that areas, we can do a lot of contribution by providing refrigerated or not refrigerated. You can just reduce the temperature to 12 or 15 degrees centigrade, then these vegetables will be okay. That's another area where we want to work. And we have already discussed with the Fisheries Department of Kerala. They have a big problem. They have already given thousands of seeds, that means small fishes, to inland farming centers.
and thousands of fishes are there in small ponds in lot of houses, especially in remote areas. But they are not able to take these fishes to the market because the fishes will be dead. So we are planning to do an electric vehicle, make an electric vehicle with a live fish, where the fish can be kept alive by providing aerator and other things. So live fish will be coming to the market. With the electric three-wheeler will be equipped with a tank, and that project is also live. I think maybe within 1 or 2 months it's going to happen. I think everybody here will be excited about the cinema and other things. Our company Innovation Experience is also into cinema field for the first time. 2 months back, we decided to make a film, commercial film. Actually, it was planned. It was a 5 year or 6 year. Actually, it was 5 or 6 year before we planned it. And right now, we have did that film. The specialty is that we made this film by avoiding diesel generators. We took the entire film with the solar power, and actually it was supposed to take it with the electric vehicle also. But unfortunately, at that time, we tried to get an easy Pro from Anand, but it was not available. But by using a Maruti Omni, we did the filming. The shooting process is over, and I would like to. This is the picture of that solar-powered filming unit, and I think you might have heard about some of you might have heard about ACE Engineering College. Major portion of that filming was done at ACE Engineering College, Atlanta, and this is the top view of the solar power unit fitted on a Maruti Omni van. But instead of Maruti Omni, if it is a e-Supro or another electric vehicle, it will be fantastic because completely electric powered, renewable energy driven film, first of its kind in the world. So we have anyway we have completed the shooting. The post production work is going on. Within the next 2 months, that film will also be released. In that film, there was a love song was picturized, and we used an electric vehicle for the picturizing that. I will show you the picture. This was an electric boat, but it was remote controlled. Normally, while doing the filming, the person will be sitting in the boat with the rope, so that he will also be in the picture. So we cannot avoid the full. We cannot take the full picture of the boat because that boatman also will come. So here, what we have done is we have did it remotely. So this is going to be the future. Or in tourism sector, remote control or GPS controlled driverless boats in a specific confined area. It is easy to make driverless boats. Driverless cars are not so easy because, for example, in a 10-acre pond, you can easily do the driverless boat, especially for tourism. And there is no upkeep. It's very easy. Constant power is required. So this is another area where we are working. These are the filming thing happened in the forest where there is no power. We have did the filming. So in my company there are 2 directors, myself Shyam and Sat here, but the other man is Thomas Tenikera. He is settled in Virginia, USA, and he is doing some of our projects there in USA also. Thank you for listening to me. Any questions? Okay, so I'm handing over the Chandan.
Show of hands who is from software background. Purely software background. Automotive background, anyone? So these guys, you have to appreciate them separately because these are the pioneers of EV in India right now. Because someone had to take the risk, someone had to travel from Mumbai to Trivandrum, someone had to go from Delhi to Trivandrum. And I think people are now trying to go to Leh Ladakh with electric vehicles. So someone has to do that so that we understand what is missing. Where do we have a problem with the charging stations? And we'll try to plug it. The government will eventually do that. So about me, I'm Chandan Satish Chandran. I'm the CEO of Zito Motors. So I've previously worked with Tesla in their production in Netherlands, and before that I worked with Punch Powertrain in their battery thermal management system. So let's get started. So the hottest topic right now. This was one of the questions that was asked. So why is keenest of you might be saying, okay, that's not an EV, that's a IC engine vehicle. So why did you put a picture of an IC engine vehicle? So I will tell a statistic. So for every 100,000 vehicles sold, IC engine vehicles sold, there is a fire of 1,529 on average. And for every 100,000 EV sold, there is only 25 cases. So why is there this uproar about EV fires? Any guesses? Anyone want to gather a guess as to why there is so much importance to an EV catching fire? Yeah, the reason is you need three things for a fire. You need the fuel, you need the oxygen, and you basically need the heat to run the fire. So when it comes to ICD fires, you basically can starve it. You can just cover it with a blanket, and if you remove oxygen from the equation, the fire dies out. Problem with lithium-ion batteries are that the lithium salts themselves are self-oxidizing. So what it allows it to create is oxygen. So basically it has its own oxygen. So even if you starve it, it might die off in say 5 seconds or 10 seconds, it will die off and it will come back again. So this makes it very difficult to contain the electric battery fire. And this is one of the reasons why even if a battery is very well tested and approved by any agency, you should probably not look at charging it within the confines of your home, because you could basically trigger a cascading fire into your entire house. And there was cases reported like this, which prompted the NITI Aayog to start a committee to evaluate the possibilities of open BMS. So Trespark, including Zito Motors, is part of the committee, identifying what needs to be done to avoid such catastrophe in future. So here you can see, so this was made by a company called GMS. So this is how most of our kit assembly companies in India operate. So they basically identify someone who is willing to provide them with cell. They do not care about the grades at times. You need grade A cells for EV, but sometimes they use reused grade A cells, or they might get a grade B. And then they find a battery supplier. There are so many battery suppliers. For every nook and cranny, you have one battery supplier. They ask them to create a battery for, say, 72 volt system. They make it, they get a few trials done, they're happy with the results, send for ARI certification. The ARI certification is not the end all for everything. The testing is not so exhaustive that you will avoid any scenario of accidents happening. Now on the right side you can see, this is the actual procedure that is supposed to be followed. And you are supposed to do all this process for just for the selection of the cell and creation of the battery pack. And then after this, for the BMS, you have another 100 to 180 set of tests. This entire process is sort of skipped by most of the manufacturers right now. And you can easily differentiate them from the number of cases that are happening in the country. If you look at that, you can easily set a line and say like, okay, these guys are probably doing it and these guys are probably not doing it. And that's because they set their own internal standards. There are no set standards on how the battery BMS need to be tested in-house by the government. Government has not made any mandate regarding what needs to be tested. So it's usually done by companies themselves or consultancy companies do that for them. So this is primarily considered like the most important parts of a BMS. These things must be done by BMS. It's the minimum thing that a BMS needs to do. And there are other stuff that BMS does because there is no communication here. Basically, you need to communicate with the rider what is happening, how much charge is there. It has an internal short circuit detection, but some BMSs have external short circuit detection and so on. But here also, most of the manufacturers skimp and what they do is they put only few of these. So let's say they have the cell voltage monitoring, so they understand if you are overcharging or over discharging, but they just casually discharge like all the other important parameters. And most of the rickshawalas, they use BMSs if they have one. Some they don't sometimes have a BMS. If they have one, mostly you won't even have a cell balancing system. So when you use it like that, you're going to have issues. Constantly you're going to have issues. You need to understand what your battery is doing at every point of your EV usage. So imagine you have your mobile phones with you. So when you buy it, it says 3500 mAh batteries. So that's the state of health is 100% health it has at that time. But use it for 5 years and it will still charge to 100%. That 100% is not the 3500. It has already degraded itself to say 2700. State of health is currently that one, and you're charging SOC, that is the state of charge is the 100%. Just like that, EVs do the same thing. It basically degrades itself, and the BMS basically need to account for this degradation. So, I'm here to give an introduction on what all goes into making an EV vehicle. So it's just an introduction into all the simulation softwares that we basically utilize. So this is a crash simulation. Obviously not a good design because there is significant intrusion into the cabin, but this is what we do. Like manufacturers can test their entire vehicle instead of building it in full prototype and testing. You can see how the stresses are acting on the vehicle, how it is being transferred to the end of the vehicle. And even before a vehicle is produced, even in prototype, you can basically tell that the shell is good enough to be rated for a 5-star rated vehicle. So we are using, this is a software called Altair Radios, which we get from Presspark. So we utilize this to create our battery packs. So we can analyze how an impact would, our battery pack would take an impact. Now, okay, so this is called multi-physics models. So there are several multi-physics models. So usually a simulation takes into account only one type of modeling. So it's mechanical or electrical or electrothermal. But when it comes to cells, you have an issue there. The cells have a mechanical part, it has a chemical part, it has an electrical part, and all these need to be considered at the same time if you want to get any good results. So that's why you have micro scale simulations in which you have the mechanical properties and you also understand the electrothermal properties, and you take this into a macro scale simulation wherein you test this with the real life condition. You take this actual cell, you put compression load on it, or you put some sort of a penetration load on it, and then you observe how close your simulation is to the actual result. You get the data from the cell, which might explode probably, and you try to recreate the same data by modifying these parameters. In the end, what cell you are left with is good enough to replicate the entire EV battery cells. You can use n number of those cells in a battery pack, which you can use to test different collision scenarios. You can test how the battery pack is going to sustain an accident. And usually what we look for from this simulations is to see how the fire propagates. EVs, no matter how well you design, there is always a scenario where you could initiate a fire, especially when you're working with really powerful lithium-ion cells. So in those scenarios, you need to still provide some time for the passengers to escape the vehicle, or at least make sure that the fire does not propagate throughout the entire vehicle and thereby destroying the vehicle. So these are the for component development. You have softwares which basically can simulate almost the entire process of creating. So here it's a motor. So this is called Altair Flux. So wherein you can create motor with your requirement, your efficiency. You can set the magnets, whichever topology you want to use. And then once you're done with the concept design, you go through it with the detailed design, where you can see the magnetics, how the magnetics is going to affect, how the thermals are, and if some sort of harmonics are being created, the NVH is getting affected, or the durability, question of durability comes in, and how the magnets are going to react when you are spinning this rotor at say 10,000 RPM. And then also you can look at CFD, you can look at how to cool the battery pack. So from an initial design with a scenario, you can go to electromagnetics, thermals, mechanical, and you can do a continuous optimization of this process, and that will completely automatically, and to get an optimal design for your application. So this is a vehicle simulation. So this is actually one of our own. So in here you can see different blocks of the vehicle, each of which will have its own internal physics which is running. So this has an MIDC written, which is a modified engine driving cycle. So you can select different cycles. You can make basically have your vehicle run in Europe with a different ambient temperature, with a different drive cycle. You can run WLTP or you can run NEDC. Then you have a controller part of it, in which you can basically limit the vehicle to sports mode or eco mode, and you can tell what sort of controlling we are providing. Then we have a motor drive, which basically has different types of motor. We have PMSM or IPM PMSM or different types of motor that we want to implement. We can provide all of that into the motor drive. Then we have a reduction, and then we have vehicle body, and the vehicle body has different elements taken from other physics solvers. For example, aerodynamics will have a solver within the vehicle body. You'll have tire dynamics. Tire deforms in a different way, and it's not easy to generate that one. So we'll have a solver for that one running inside that one. And the end result of this is like you can see some of those end results here. This allows us to do really fast computing of what we are trying to simulate. We can basically check how much range improvement there would be if you use a new battery pack or a new motor, or if you change a control strategy, what would be the outcome of that one. So we use multi-body dynamic simulations. So for example, if you look at a company like Hero Honda or Bajaj, they have a huge part built, and they have decades and maybe century of experience with them. So for them to basically create a new vehicle is not so complicated. They can pick from the parts, create a prototype, and it's good to go for them. But for a startup, for us, everything is a new question. Like, how do we set the seat position? How do we set the handlebar position? What should be the length of the bike? What should be the ground clearance? All these questions come into mind. So we create these multi-body simulations in which all these elements can be varied. We can vary these and study the effect of these modifications. So for example, here you can see the vehicle is actually doing a double lane change and ending in a very bad wobble, but we can perform these simulations, and we can continuously perform these simulations. In a matter of 5 minutes, you can change different damper settings, different spring rates, and in the end, you can come to an optimum design even before you have started to design the final vehicle. Not even done a CAD file, you have already designed what should be the hard points of the vehicle. So, adding to that multi-body physics engine, you can add one more, which is the multi-flexible body dynamics. So this is where you basically have like a member or a material which basically can deform, and you want to see how that deforms, how the pressure or forces are building on it. And this also allows us to model very complex parts which have huge deformations. So for example, in this one you can see there is a significant deformation, and using conventional methods you will not be able to simulate this. And I think earlier it was discussed how important for an EV aerodynamics is. Aerodynamics is very, very important because that is one area we can shave off quite a lot of energy usage from an EV. So here you see Vision EQ XX. This is from Mercedes. This is a prototype, but this has a on-road range of 1,000 kilometers. So making it one of the peak performing EVs in the world. So how it is able to perform this sort of range is purely down to its aerodynamics. There has not been a huge jump in efficiency of motors or batteries. It's all comes down to how it was engineered, and it was engineered ground up. So keep this in mind, because as Nexon is not a ground up built EV. The ground up built EVs have some strength. They can package much better. They can have the batteries in the floor. It will be here below the vehicle's center of gravity will be much lower because of this one, and you'll be sitting on top of the battery instead of placing it somewhere over here, just under the seat. And you'll have motors that are right in the center of the axle and not placed above here. Again, if you have a motor above the wheel, then you basically have to provide some sort of a paneling above it. This will basically stop you from making it more aerodynamic. You'll have to make compromises. Current motor sizes at Tesla is the size of a watermelon. So that's it. That takes to create around 500 bhp here about. So you can place it much more compact. You'll have a lot of freed space. You'll be sitting in much more comfort. And also, when you develop a platform ground up, you'll have a lot of control over it. Because an EV, if it's an EV, there is no noise that you're accounting for. So even if a single panel on the vehicle is going to rattle, you're going to hear it. But on an IC engine vehicle, you have an engine that is covering the sound. So you'll probably not listen to that, or you'll not listen to brake squeal or anything. But in an EV, you'll start listening. That's why dedicated platforms are very important. And aerodynamics plays a much significant role in that one. For context, this has a CD value. CD value is the coefficient of drag. Drag is how much it is being pulled by the air. The value is around 0.17. That is industry's highest right now. For comparison, you can look at Maruti Suzuki Swift. It has a 0.38. Higher is worse. And if you take a truck, it has somewhere in the range of 0.8. So if you have three vehicles, this one, a Swift and a truck, all of them, imagine they have the same powertrain, same weight. If you run for 1 kilometer, this will still be more efficient. So how we utilize this is we also perform simulations on aerodynamics, because this is one region where we can get some more range, because the Indian motorist national anthem is Kitna Deta Hai. So we basically have to answer to that one. So we observe how this is one of the initial simulations, there is no rider on it, I know. We were just observing how the frontal area is performing here. And we observe how the air is traveling around the vehicle. So if you look at most of the EV motorcycles in India, it's either scooters or they have big panels on their side. And the reason for the big panels is to make it as smooth as possible. So every bit saves a little bit of kilometers. So adding to all the improvements in EV, AI is going to play a significant role in how EVs are going to evolve. Not just EVs, generally in every field you're starting to see it. Healthcare, you're seeing it in retail, but automotive also you're going to see the impact of AI. From design, how it is designed. So I'll show an example of the design part of it. In supply chain, there is significant improvements in AI, using AI to identify how to improve the supply chain. In production, we have different material handling systems which run completely on AI. So imagine you want to take a motor from a position X to Y in a plant. The AI can detect what is the easiest path to get there, what is the safest path to get there. And then you have post-production also in delivery and so on. Then you have driver assistance system. So advanced driver assistance system where the vehicle would brake itself and save the driver from an accident. And you have autonomous driving. You must have heard of this one. Tesla doing its own testing of autonomous driving right now. So it uses AI to basically compute how to drive, or basically using a preset number of conditions and machine learning. It's basically improving itself on how to drive. And then you have cloud computing, wherein quite a lot of activity that used to be done using hardware on the vehicle now is being exported to an offsite system. You have driver risk assessment and monitoring, so the AI-based systems can now understand how drowsy a driver is, or is he paying enough attention. And also driver monitoring and driver risk assessment, how bad a situation is the vehicle in, to have an accident. This can be evaluated by AI. And you have predictive maintenance, insurance, and so on. So we are currently working on SOC estimation using AI for our BMS, so that it improves over time. There will be two parts, one of the vehicle which will do the basic parts of things, but constantly on the background it will be collecting data and it will be improving itself. So this is one part of the design side I mentioned for AI. So this is called generative design. So earlier we used to design a part from pure experience using CAD. Now we basically tell the system these are the things to be preserved, these are the obstacles I have, these are the load conditions I'm going to provide. And then I tell the system, okay, I need to do it in additive manufacturing or milling process, what process I want to follow. And it will create n number of options with different capabilities. And once these options are generated, it will give an option to choose these or shortlist or filter these using what I specifically need. So I could make decisions based on whether it is easier to manufacture or not, in which geography that product is going to be sold. Maybe on the cost basis, if there is a significant cost constraint to that one. And also, apart from this, the current generation of simulation softwares also allow us to simulate manufacturing of this part. So this part in this entirety can be observed how it is simulated, how it is manufactured. And we can do CNC milling and machining process all the way down to how it will be on the vehicle. Some limitations of these technologies now is that 3D printing for metal components are very expensive. And making a part like this on a vehicle in India would be like costing the vehicle itself. So that makes no sense. But down the road, we believe there will be components, there will be companies that develop this process like laser metal sintering process. When they improve the process, make it faster, cheaper, we would eventually be able to purchase a component from the internet and we will be able to print it at a nearby printing station for your use. So this is one of the parts that we optimized with generative design and topology optimization, which is just one subsection of the generative design. So what we are working on right now? So we have created a battery agnostic, a cell agnostic EV battery pack, which allows us to use cells with different chemistries. With small changes in algorithm and the thermal conduction pads, we'll be able to use more than one cell inside the battery pack. And also these are modular, so 8 years down the range when your battery is about to die, you don't have to replace the entire battery pack, you replace only the modules that you failed. Because like it was mentioned earlier, it's a 50% cost of the vehicle. And also, just like how the car industry has done now, so we created a platform instead of a single vehicle. And what a platform allows us to do is, for example, you design a platform, you can use it to make an SUV or a hatchback or any vehicle that you want. You basically create the platform and then you work around it. So that's the same approach that we have taken. We created an adaptive modular platform for different use case scenarios, which can be extended to up to 8 different applications. Just a teaser of what the product is. That's it. Thank you. Questions? No, we are focusing on the performance side of things, because if you observe the trend of scooters from the time Activa was launched has been on the rise. The commuter segment bikes have sort of started to die off. Whatever was differentiating those two segments has basically blurred out now. So in future, when it goes electric, I would like to ask a question, like if you are given a choice to spend 1 lakh more on a commuter bike to get a high performance bike, and there you don't have the concern of petrol, how much you have to spend for the fuel. Wouldn't you buy a performance bike? So yeah, so the performance bike category is what we are after, but not to the extent where it is the super bike, it's competing with the super bikes or the Harley Davidson, much below that.
What's the performance you are actually
We'll be getting somewhere in the range of 8 seconds to 0 to 100 and a top speed of 135 and range in the extent of 200 kilometers. As of now, last tested, we'll be getting 200 plus of range. There is a reduction drive inside, so the wheel torque will be somewhere in the range of 320 Newton meters. Generator design. As of now, topology can be done with Altair softwares. Altair has generator design as well, and I think ANSYS in the newer segments have a section for generator design. But yeah, you need specific software if you want to do extensive improvements in that one. But topology can be done with Altair softwares.
You mentioned three or four simulation software, right? The aerodynamics, the motor, and for design. So do they give absolutely 100% accurate results?
No. So what we do is, for example, we have a mentor from UK. So he is from Loughborough University. There we have a wind tunnel, actual wind tunnel with a full-size wind tunnel. So we can create a miniature model of our vehicle, send it to him. He can run the actual simulation and tell that how close our data is, the CD values, whether the turbulences are sensible enough from the simulation. And we continuously iterate the simulation to confirm that the data is right. And it's always supposed to be done like that. You want to simulate something, you want to do a physical part of it. Maybe you don't do the full part of it. For example, you want to test 200 battery packs crashing on the ground. You don't actually make 200 packs and crash it. You make 2 or 3. You observe how it is reacting. You do the simulation. You do 100 tests, 200 tests, and then you come back and you modify the actual battery pack. And then you make a new battery pack. And on that new battery pack, again you run the simulation. And you continue this process until you are happy with the results.
What is the capacity of the battery pack for your bike?
We have, like I mentioned, it's a modular architecture, so we can go all the way from 5.5 to 9.5. We have space for that. We have capacity for this. By using different capacity cells, we'll be able to push higher. Yeah. Yeah, I get that. So EVs as of now, if you look, even the OEMs that are going to enter, they want to enter into the market which they have strength in. Their strength is in scale. They have huge manufacturing capability. They have such a huge partner. Their supplier base is massive. You want to compete with them. Imagine Activa sells almost 1 lakh units per month. Compare that to Ather, which sells 3,000 of the same segment vehicles. So you'll be struggling to keep up with companies like Activa. But as you go up the market, you go to say Royal Enfield or Bajaj, the top end of KTMs and so on, you have much less competition and you have much less demand initially. And once we make ourselves as a brand, as a known brand, then we have the capability to scale it down. With, like I mentioned, the battery pack has the modularity, so we can bring the capacity down so that the price basically makes sense in the scale that we want to produce. We are not targeting at large volume production of cheap vehicles. Instead, we are going at low volume production of expensive vehicles.
I have very generic questions. More and more electric vehicles coming up, the electricity consumption is eventually going to increase. Right? And already India is going through a power crisis now. There are lots of parts of Bombay where there are power cuts already. So does government have a plan to increase electricity production? Because it's no more fuel which is going to run the vehicle, it's electricity in addition to the household and industrial electricity.
Yeah, this shortage happened because the coal reserve that we usually keep, all the companies are asked to retain a coal reserve, which is very small. It's sort of like a just-in-time sort of method, which is not very ideal. If there is any sort of shortage or a huge rain which is causing the coal not to be extracted, you immediately are going to see the effect of it
because the entire infrastructure will basically run out of coal in 2 days. So that should not happen. That's what happened right now. So now probably government will look at increasing this buffer. So you will basically be eating up into the buffer, but not too much. So I think that's something that government was hinting at. And this shortage is not going to end. Like you are using coal, you are going to have the shortage. There are countries like France, which is very dependent on nuclear power. For them, electricity is much cheaper and it's much more cleaner actually. And the same, the neighbors, the Belgium, they basically buy it from France. Even their own nuclear power plant, they sold it to France and then buy electricity from them. So, owning an electric vehicle in Belgium is much more expensive to operate than in France. So, this is there with everyone. Every country has this sort of constraints. But like Sir mentioned, like you'll have solar-based systems. All the charging stations, if they go completely solar, we can offset quite a lot. And mostly we will not be 90% of time, 95% of the users will not be charging their EVs on the fast charging solutions. You guys will do it because you're on a long distance trip. How many people would actually do a 200-kilometer commute on a daily basis? We did this survey in the initial phase of beginning, and most of the customers are in the range of 30 to 40 kilometers of daily requirement. But if you ask them how much range you want in the vehicle, they say 500. For what reason I do not know, but they say that. Thank you.
Thank you, Jordan. So it was really great way to restart the event, and thank you so much for everyone who came today to be part of this program. So I request Jones to come forward. So he was a former principal of Harvard Business College, and he came here.
So what do you just take it,
Good evening. This is the first time that I am attending the talk here. In fact, it was very, very informative, and the talks were on the latest technologies and the real life case that we have seen, the travel from Bombay to here. So the experience they shared and the technologies, the latest trends in technology in EV vehicles. And one doubt I have is regarding the solar systems that you have developed. Still it is in the development stage, or is it commercialized? For example, the solar powered auto rickshaw and such things. Okay. What this commercialized and is yes, okay. So very, very informative, and thank you very much for inviting me. And
so I request you to hand over the gift to our speakers. So, Gautam, so this is your first FAYA opportunity, so everyone will be wondering like when you started with the EV story. So, how do you feel right now?
Really good. So, this is the first FAYA 80 event that I'm speaking on, but I've known FAYA 80 from the time it was Coffee with DBG about 9 years back, and that's when we actually came to the first Coffee with DBG event. A great initiative, a very popular event, I guess, all across Kerala in the startup community as well. where lots of such informative talks happen, and we get to learn a lot from these interactions.
So, is there any suggestion for the topic for the next FAYA board meeting? Because today, we started with EV, so whether we need to continue with a series for EV or let me just close and go to the next topic. Is there any suggestion? For any topic for the next?
Renewable resources.
Renewable resources. Okay. Okay, so let's hand over the small token of appreciation for the speaker. Go. So, Dr. Koshi, so, Shyam? So, I was wondering how you get time to do all these different type of stuff. Movie making. A lot of activity.
It's basically time management. That would be time management.
Yeah, and Chandra. Thank you, sir. And normally we formally wind up the session and everyone can stay back and interact, and we will go to Google I/O extended, like it will start at 8:30, right? Today 8:30, 8:39, it will take some time. She has to go there, and Farish is also there. Farish, please. So he also came to organize. He's from Google, and what is your experience on FAYA 18?
And this is my first FAYA meeting. I mean, I didn't know that this is your 91st. So I don't know how long you've been running this, but this is amazing. And when you guys started talking about your journey, I didn't know what you guys were talking about because you mentioned that you never had an experience around EV. I thought you guys are EV startup, but it was an insightful session. So very interesting. And looking forward to having all of you at IO extended event. I think we'll be starting at 8:30. Yeah, so good to be here.
And also
if you're going to be there, probably I'll talk about that there. But I'm part of a team called Google Developer Ecosystem. I primarily run a team, a program called Google for Startups Accelerator Program. So if you're a startups looking for support from Google, please feel free to talk to me. Looking forward to your interaction.
Thank you, Farish. So, you want to run the quiz here or you want to run the quiz there? We will do it there. Okay. So, any other questions? So, Richard is there. Yeah. Engine robotics. Now, you will do the thing.
So, great event. So happy to hear these stories. Meeting Shyam after a long time. And also so proud to hear the story of Cito Motors.
Thank you. So, Jiku. Okay.
questions or answers everything. Actually, we can probably close this session.